Welcome back to week 10, and in video 2 we are going to talk about past and future climate change. So we went over some of the evidence that we see. Next we're going to talk about how the Earth's climate has changed in the past, what's caused that past climate change, and then how climate might change in the future. So some of the causes of past climate change include changes in energy output from the sun, Earth's rotation or orbit, fluctuations, geography of the Earth, and atmospheric composition. These causes trigger climate change and can actually be reinforced, positive feedback, or inhibited, negative feedback, by other physical processes. So these causes all can work together to positively feedback and then cause climate to change, or they can work against each other and to keep things the same. So some of these things include, like I mentioned, solar output. So the energy released from the sun can change over time. If we look at this graph from 2005 to 1980, you can see the sun's energy output has fluctuated over time. And then we can actually look at the global surface temperature, and we see that things kind of fluctuate in a somewhat similar pattern to that. So we can see that cycle in the Earth's global surface temperature, and these cycles are much, much smaller. You can see here, we can actually see it in our record. We can also look at the Earth's geography. Throughout Earth's history, we've had changes in the location of where the continental plates are located. So at one point, North America was at a lower latitude, so closer to the equator. Also, mountain ranges can form over time and can divert and change weather patterns. So before the Cascades existed, this area would not have had that rain shadow effect that we see today. So the creation of mountain ranges through plate tectonics can help to change local climate as well. And also, if we have a lot of volcanic activity, that can produce carbon dioxide, particulates into the atmosphere to help change things as well. The other thing are some other cycles that exist with the Earth's orbit. There are numerous different ways we can look at this. So there's what are called the Milankovitch cycles. Make sure you check that out in your textbook. So these all have to do with the Earth's orbit. So is the Earth orbit more eccentric, so kind of like an oval shape, or is it more circular? The tilt of the Earth's axis, is it tilted more towards the sun or more away from the sun? And the Earth's axis also has a wobble to it as well. So a lot of these cycles change, and some of them are short, geologically speaking, 20,000 years. Some of them are even bigger, 120,000 years, 200,000 years. So some of these cycles are much, much bigger than the cycles that we saw here with the changes in solar output. So those are our main causes of past climate change. All of these can produce various triggers. So if we have everything lining up, like we have low output from the sun, the Earth is further away from the sun, we can be in a time where we have much cooler conditions because there's less solar energy getting to the Earth's surface. So what's happened throughout the past? Well, we see a series of global warming and global cooling cycles. And when we have warming occurring, we have increased global air temperature trend. We end up with increased sea level, decrease in ice cover, increased ocean acidity, more energetic storm systems. When we have global cooling, decreased global air temperature trend, we have increased ice cover, lower sea levels, and ocean acidity decrease. So to kind of take a look at what these cycles look like here, I have a website that you can visit that has the same image here that I will pull up for you. And this website actually shows you lots of different items on it. So you have to scroll down to get to this specific graph. So when we look at, we have few different graphs here. So these bottom two that we see have the same time scale going from 2000 back to 800. So pretty far back. And also on here we can look at temperature, and how the temperature anomaly has changed over time. And you can see you have pretty big fluctuations back and forth, and then we end up with black line on here showing you measured change based on instruments that we have today. We can also take a look at the temperature reconstructions from various locations and various dates. Here you can see all of these abbreviations indicate locations where this data is taken from. If you visit that website, you can get an idea of where this information is from. So this is only going back 800 to 800. But if we look closer at the more recent time frame from about 1700 to 2000, we see an overall increased trend in our temperature here. So past climate, this is short-term scale. We can also look at long-term scale. And here's one of those ice core data cores. We can see going back thousands of years. This is age in thousands of years before present. So we have present on the left side and then going back in time towards the right. And here we can see lots of information. So this information we see in the bottom graph. We've got our delta, or a change in oxygen isotope ratios. We can see seawater numbers. So we have all these different comparisons on here, tons of data shown, but basically we see that things have fluctuated. We see differences in oxygen isotope ratios going back historically, and those oxygen isotope ratios just tell you about the climate change. So if we have more oxygen 16 in the glaciers, that means we have a cooler temperature. If we have less, that means we have a warmer temperature. Ocean conditions, it's the opposite. If we have more oxygen 18, that means it is cooler. Less or more even ratio, then we have warmer conditions. So ice core and ocean floor cores go back much, much later in Earth's history. So the other thing I wanted to show you is this geotime program that Frank Granshaw has put together. So here we see current conditions where we are. Lots of different options that we can show here, but we will just go back in time here. If we go back 20,000 years, we see lots of ice. This is the last major ice age. You can see huge areas of ice, and then also if you look at the US, we see much more land cover in a lot of places where the continental shelf is very shallow. So if I go forward again here, you see ice melts back to current conditions and our sea levels higher. So all these light blue areas in the oceans, you can see when the water is locked up in the ice, we see the sea level has dropped. Cooler conditions. Go back a little further, we see very, very small amounts of glaciers. This is 35 million years ago. So our glaciers are smaller than they are today. We see lots of areas where we have flooding, like Florida doesn't exist yet. And then you can see how the plates are actually changing over time as well. We go back 50 million years, major changes in our plates. Glaciers are even smaller. Go back 65 million years, this is dinosaur time. Very little ice cover, very warm conditions globally. 90 million years ago, even warmer, zero ice present. High sea levels because there's no water locked up in glaciers. 105 million years ago, you can see as we move throughout time here, it's all pretty warm conditions, no ice. Plates are shifting, and then about 260 million years ago, this is where we have increased ice cover again. So we have a glacial time period here. More ice sticking around, and then around 370 million years ago, we end up with no ice again, very warm conditions. The Devonian is known as the age of the fishes because this is when fish evolved and diversified. When we keep going back in time, we see Earth looks much, much different, but again, we have another glacial period, 600 million years ago, and then this is where things get a little confusing because we don't know exactly what happened this far back. But if you go back forward, see things shifting, ice appearing, disappearing, and then current conditions, what we see today. So That's kind of an overview of what has happened in the past. So if we think about what might happen in the future, a lot of what happens in the future depends upon how much warming we have in the next 100 years. So short term, in the next few centuries, we'll probably see a continued warming trend globally, a continued change in global temperatures. We'll see increase in sea level and coastal flooding because as the glaciers melt, they're redepositing that water back into the oceans. We'll see an increased storm intensity, which we're already seeing now. We'll see decreased ice cover, and then we'll see climate zones changing. I would definitely check out the videos that I posted from ESF because the meteorologist there in Syracuse, New York, goes over some really, really interesting information about climate change and how it will affect weather patterns. Long term, depends on how quickly the warming that happens in the next few centuries happen. There's various models that have been run that show maybe the continued warming trend will happen. We'll have just increased warming until all the ice is melted, causing a really significant increase in sea level. Or if we could have this increased warming throw us back into a cooling period. And we had one of those in the 1700s or so, which was called the Little Ice Age. And this was when we had a global cooling event that occurred all around the world, and we see evidence of that in the glaciers and the Cascades. We see huge moraines that exist from the Little Ice Age. If you hike up to Elliott Glacier on Mount Hood, you can see these huge moraines. Some of these hikes go right along the ridge lines of these that were deposited when things were cooler, ice was bigger. Also, we see paintings from Europe where a lot of canals were frozen over during this time period, when today they do not freeze over, so we see a significant change there. So it's a possibility. It depends on what happens in the next few centuries. So this top graph here, I'm just going to make it larger here for you to see. This top graph is showing you the predictions for the future. This is all from the IPCC website. So what they've done is they take past data that you can see here. The black line is the average. The gray line is showing you the error. And as we get to more recent times, you see that error decreases and even disappears because we're getting into times where we have actual measurements, whereas in the past here we have a lot of historical data and very little actual number data that we can see. So this is past information that we have, and then taking all that information and plugging it into various models, they have come up with 3 different scenarios. And these are represented by these 4 different graphs. So if we have consistent 2000 year emissions concentrations of greenhouse gases from the year 2000, if we don't change, we don't increase at all, the orange line here on the bottom is what we could see in the future. The next few are different scenarios saying maybe we increase by X amount, by Y amount, by Z amount. And that's what these 4 different graphs represent. So you see all of these, if we increase our emissions, we increase our temperatures. And we can get into some pretty scary stuff. If you're curious about this graph, you can check out the IPCC website. So if we look at this bottom image here, we see present day, 1990s, not exactly present day, but pretty close. Our surface air temperature here, and the predicted for 2090s, you can see the second one. You can see the equator heats up quite a bit. Poles heat up a little bit. This graph might not be totally accurate because we know that the poles are definitely going to increase significantly. With that increase, we know that we're going to have sea level increases, and here is a long-term relative sea level trend for the U.S. So this is sea level trends that were calculated at about 117 locations using at least 30 years of sea level data. More than half of these stations see a greater trend than 2 millimeters per year, which is a lot. I know it seems small, but it's a lot when you live on a coastline. And these things may vary. If you're curious, you can check out this website here. In our neck of the woods, we see a 0 to 3 millimeter change per year. East Coast areas, we see maybe 3 to 5. So we can see some areas are going to see significant change. And this isn't 1 year. So if we look at 10 years in the future, we're going to have a pretty large change. So coastal areas, you may hear in the news, coastal cities are starting to think about this change that is happening and will continue to happen. So that is our overview of Earth's climate, past, present, and future. Check out the links that I have posted. They were definitely helpful to you, and I will see you in lab.